Welcome back, everybody. My name's Mr. Swaner, and today we're going to talk about simplifying square roots without any variables. Before we begin, make sure you pick up your companion notes so that you can follow along to this presentation. And let's start with just a brief review of what square roots are. Just like multiplication and division are opposites, square root and squaring is opposite as well. So a square root is the opposite of squaring a number. So for example, if I have 6 squared is 36, the square root of 36 is 6. So it's the opposite operation of squaring a number. So just another example here, 10 squared is 100, and the opposite of that, the square root of 100 is 10. Okay, and let's look at estimating some square roots. Now, we have some perfect squares. You should be well aware of perfect squares. And we see that we have here square root of 30. This is not a perfect square, but we can estimate where this is on the number line by finding the perfect squares before and after it. So one of the perfect squares that we know is 25, and the other is 36. These are the two perfect squares that surround the square root of 30. And I know that the square root of 25 is 5, and that the square root of 36 is 6. Well, the square root of 30 is somewhere right in the middle there. So if I was estimating, I would say that the square root of 30 is approximately 5.5. So let's look at another one here. If I have the square root of 70, this is not a perfect square, so I'm going to look before and after 70 for my perfect squares. And I know before 70 I have a perfect square of 64, and after 70 I have a perfect square of 81. So the square root of 64 is 8, the square root of 81 is 9, and 70 is kind of in the middle there, but it looks like it's a little bit closer to the square root of 64 than it is 81. It's a little bit closer there, so if I was going to estimate, I'd say it's right in between 8.3 and 8.4. Again, we're just estimating. If you said 8.5, I think that's a reasonable estimate. However, we could make a little bit closer estimate. But let's talk about multiplying and dividing our square roots. Square roots are really fun because you can multiply and divide the square roots or radicals just like regular numbers. So if I took the square root of 3 times the square root of 4, I would get the square root of 12. Just like 3 times 4 is 12. So it makes things really nice and easy when we have a rule that works across the board. So just another example here, if I have the square root of 9 times the square root of 5, I would get the square root of 45. And we could also divide these square roots in the same fashion. So when we talk about simplifying square roots, what we're trying to do is factor out any perfect squares that we possibly can. So let's start with a really basic one. We've got the square root of 24. Now this is not a perfect square, but we're going to try and break this up into factors of perfect squares. So there's a couple of different ways we could make 24. We could do 2 times 12. I don't see any perfect squares there. We could break it up into 3 times 8. Again, I don't see any perfect squares standing out to me yet. Or we could do 4 times 6. And I know that 4 is a perfect square. 2 squared will give me 4. Therefore, 4 is a perfect square. So I'm going to break the square root of 24 up into the square root of 4 times the square root of 6. And I can take that a little bit further. The square root of 4 is 2. And I'm just going to tack on the square root of 6 here. And that's my final answer. If I break the square root of 24 up, I can pull out a factor, square root of 4. I can pull that out and simplify this further. Okay, so let's look at another one here. I've got the square root of 18, and there's a couple of different ways that I could make 18. I could do 2 times 9, or I could do 3 times 6. Both will work, but only one has a perfect square in it, and that's 2 times 9. 9 is a perfect square, so I can find the square root of 9. I know that 3 squared is 9. So I'm going to break the square root of 18 up into the square root of 2 times 9. Again, I know what the square root of 9 is, and that's 3. So I can rewrite this. I'm going to put my whole number out front just to rewrite this in the correct way. And my answer is 3 square root of 2. 3 times the square root of 2. I'm going to leave that multiplication dot out of there. Okay, so hopefully you're starting to get the hang of this a little bit. Let's look at another one here. So I've got the square root of 50. Well, there's a couple of ways I can break this up. I could break it up into 10 times 5, but I don't see any perfect squares there. Or I could do 25 times 2. And I do see that 25 is a perfect square. So that's the one that I'm going to choose to use to break this apart and simplify. So I'm going to break up the square root of 50 into the square root of 25 times the square root of 2. I know that the square root of 25 is 5, and I can't do anything with that square root of 2, so I'm just going to tack it on there. And that's my answer. I've now simplified this square root. Okay, square root of 54. How do I get 54? Well, there's a couple of different ways. The way that I'm going to choose is 9 times 6 will give me 54. So I'm going to break this square root up into the square root of 9 times the square root of 6. And I know that the square root of 9 is 3. And then I've got the square root of 6 here. And now you may be thinking, well, hey, 6 can be divided up, and yes, you're absolutely right. 6, I could divide that up into the square root of 3 times the square root of 2. But when I do that, I'm not getting anywhere with it. I don't have any perfect squares that I can pull out. So I'm going to go ahead and just leave that the way it was. The only reason I would break this up further is if I could pull out a perfect square and simplify it a little bit more. But this is not the case in this problem. So let's look at the square root of 32. There's a couple of different ways I could make that. Let's do 4 times 8 because that's what comes to my head when I hear 32. I think 4 times 8. So let's go ahead and break the square root of 32 into the square root of 4 times the square root of 8. And I know that the square root of 4 is 2, and I'm going to tack on the square root of 8. Now here, this is where I need to be looking, can I break 8 up into any perfect squares? Can I pull any perfect squares out of there? So I have to start thinking to myself, what times what will give me 8? And I know that I could break this up into the square root of 4 times the square root of 2, because 4 times 2 is 8. And now I've got this square root of 4. Well, I know the square root of 4 is 2, so I'm going to pull that out as well. So I've got my 2 out front that I had already pulled out, and now I'm pulling out another 2, and then this square root of 2 is going to come down, and then the last thing I can do is I can multiply 2 times 2 to get 4 square root of 2. So in this case we had to pull 2 things out. Had we recognized that I could have used 16 times 2, I could have easily broken out and gotten that 4. It's square root of 16 times the square root of 2, I would get 4 square root of 2. So had I recognized that right off the bat, that would have been great. Unfortunately, I didn't. So now we've got 3 times the square root of 40. I already have a number sitting out front, and that's okay. I'm going to go through the process just the same way that I was before. I'm going to try and break up this square root of 40 into some perfect squares. So I know that I could do 5 times 8. That'll give me 40. I don't happen to see any perfect squares there. However, I could break up 8. Let's see if there's anything better that I could use. Perhaps 4 times 10. I think I'm going to use 4 times 10 because I see 4 is a perfect square. So I'm going to rewrite my 3, and let's break this up. The square root of 40 will break into square root of 4 times square root of 10. And now I know that the square root of 4 is 2, so now I have 3 times 2 times the square root of 10 I'm going to bring down here. So let's go ahead and do 3 times 2. 3 times 2 is 6. And then I have a square root of 10. And I need to look at this square root and see if there's any other factors that I can pull out. The only thing I can think of is 2 times 5 and 10 times 1, neither of which are perfect squares, so breaking this up isn't going to do me any good. So I'm going to go ahead and leave this just the way it is. Okay, here's another one. I've got 2 square root of 12. Okay, well, I see 6 times 2 or 4 times 3. 4 times 3 is the one that I'm going to choose to use because 4 is a perfect square. So I'm going to bring down my 2 and then break up the square root of 12 into the square root of 4 times square root of 3. Again, we know that the square root of 4 is 2, so I've got a 2 out front times 2, that's my square root of 4 that I broke up, and then times the square root of 3. And then I can multiply 2 times 2 is 4, and then I have the square root of 3, which can't be broken up at all, so I know I'm just going to leave that alone. Okay, here we have another one, 5 square root of 5. So how do I get, 5 square root of 45. How do I get 45? Well, I'm thinking 9 times 5 or 15 times 3. And I'm going to select 9 times 5 because, again, I know that 9 is a perfect square. So I'm going to write my 5 there and then break up my square root of 45 into square root 9 times square root 5. And I know that the square root of 9 is 3, so we can write our 5 times 3. And then I'm going to tack on my square root of 5 here. And now I can do the multiplication. 5 times 3 is 15. I'll bring down my square root of 5. 5 can't be broken up at all, so I know I don't have to deal with anything. This is as simple as it gets. Okay, so let's look at 6 square root of 32. Well, we could do 8 times 4 or 16 times 2. Let's go about this the long way. Maybe you didn't recognize 16 times 2, like I pretended not to earlier. So let's break this apart. I've got 6 times square root of 4 times square root of 8. And I could have written this the other way. I could have written 6 times square root of 8 times square root of 4. It doesn't really matter what order I write that down. So let's go ahead and fix this square root of 4 that I know to be 2. So now I've got 6 times 2 times the square root of 8. Let's go ahead and do our multiplication. 6 times 2 is 12. Now we have square root of 8. And I need to look, can I break the square root of 8 up into any perfect squares? And the answer to that question is yes. I can break that up into the square root of 4 times the square root of 2. And then we're going to go through the process. I know that the square root of 4 is 2, so now I have 12 times 2 times the square root of 2. And we're going to do our last little bit. 12 times 2 is 24, and we're going to tack on the square root of 2 at the end there. And that's as simple as it gets. Okay, so let's look at one more last one. Now I have 2 square root of 72. So I need to be thinking to myself, oh man, how do I get 72? Well, 8 times 9, that should come to mind. So let's go ahead and break this up. So now I have 2, and we're going to break up the square root of 72 into the square root of 9 times the square root of 8. And I know that the square root of 9 is 3, so now I have 2 times 3 times my square root of 8. Let's go ahead and do 2 times 3, that's 6 square root of 8. And then we're going to break this 8 up into the square root of 4 and the square root of 2. As we continue through the process, the square root of 4 is 2, and now I have 6 times 2 times the square root of 2. So our last step here is to do our 6 times 2, which is 12, and then we have the square root of 2. So this is just basic simplifying square roots without any variables or anything, and we will touch on that a little bit later. But in closing, to simplify a radical or a square root, you're going to break it up into its perfect squares. We're going to factor out our perfect squares and make this problem as simple as we possibly can. Well, thank you very much for joining me. Again, my name is Mr. Swaner, and until next time, study strong and keep practicing.